drawings first. Same order as we did for the presentation.
So for the agenda, we had started off with the design and the blueprint, the inspiration, the construction of the bridge, and then the reflection. The blueprint and design for our bridge, some key facts is it is a truss type bridge. The length is 58 centimeters, the height is 8 centimeters, the width is 8 centimeters, the weight is 242 grams, the estimated weight tolerance is 5 kilograms, and it took us about 5 hours to complete it. Some materials we use for our bridge, we used noodles, resin, and wax paper, and the tools we used were scissors, rulers, a protractor, measuring tape, and a knife.
The inspiration for our design was largely due to its simple yet balanced structure. Everyone's really familiar with this bridge. It's a very ancient and common type, and that made our designing and building really simple and smooth.
Obstacles during the construction. The construction of the bridge was made worse by the epoxy mixture not being totally consistent across passes, which affected the project halfway through its design. Another problem we encountered was our pieces not lining up perfectly. This could have been fixed by using the same template for both pieces. The third problem is that the resin was also hard to work with. By mixing in smaller quantities of resin, we could have been able to better attach the pieces, and just because it was really difficult to glue because it dried super fast.
During the process of designing and building the bridge, some of the following features could have helped this process: more communication, more stimulations, greater evaluation, more materials, and accessibility to other resources. To design a better bridge, we could have added more truss. This would have distributed the load further and made our bridge structurally more strong. We could have used a bridge rounded design, as this would have spread the load even better than a standard truss bridge.
So here we have our bridge. I made a suspension mechanism with some shoelaces and a box attached with a carabiner. I did it in an X pattern to distribute the load a little better. As you can see here, it's a little over 19 inches apart. That's roughly 50 centimeters, so within the guidelines. And I used river rocks for the weights. And right there, I was just showing that our supports at the top of the bridge on one side are a little bit lower to compensate for some of the twisting motion that we were having with our first build. Here, I'm rearranging the rocks. That's because it was starting to lean to one side, which was putting unnecessary stress on one corner of the bridge. which is actually eventually where it would snap. And here's the second to last rock that I'm going to put in. That was just over 3 kilograms. And it's going to fail at about 3.5 kilos. And as you can see, it broke along the bottom edge right here. This was because of our epoxy mixture being relatively weak right here. It was connected to this joint, which was the corner that had the unnecessary stress on it. The bridge failed after a total of about 3.5 kilograms. That means that the sustained load was 3.006 kilos, as the final object weighed 481 grams, the final rock that I placed in.